Hello again. So I wanted to take a moment and sort of walk you through a couple of the features on your graphing calculator that you're going to need over the course of the semester in calculus. So on the screen right now, you will see not exactly a TI-83 calculator, but a shockingly effective facsimile thereof. So if you have a TI-84, that's fine. It just looks a little more modern, I guess. It'll do all the same thing, so that's fine. Anyway, so on my screen here, I'm going to take for granted that you know kind of how to use most of the buttons down here at the bottom, how to type in numbers and get, different, arithmetic commands, that kind of thing, trig functions, that kind of deal. Before we talk about the features that come up on some of our assignments and that I'll kind of expect you to have in your toolbox as we move forward, I do want to go ahead and set one thing in place. So if you go ahead and hit the mode key, there's a whole bunch of settings here. If you've had your calculator for a while, some of these might be different. The only one that really, really matters for us, well, technically this one matters, but I've never seen a student who doesn't have it set for function graphing. You want that one highlighted if it's not already. The one we're actually going to be after is this guy right here, the radian degree thing. That talks about how we measure angles and it impacts how some of the trigonometric functions behave. For our purposes, you do want it on that precise one. So if degree is highlighted right now, use the arrow keys, kick it back over to radian. For the purposes of Math 115, that's the only way we need it configured. I apologize from the bottom of my heart if you're needing to do a lot of degree measurements and trig functions with them in another class. I'm sorry. Try to make sure you remember, for us, radians are bust. Okay, so mine is set up correctly. So a couple of the things I want to take a look at are functions of a graphical nature. So if you're wanting to generate a graph of a function, you push this guy right here for y equals. I've got a pile of mess, socked away in there for now. Let's go ahead and clear that out. And I want something a bit less, complicated. So we'll just do 2x squared minus 12x minus, no, got that. I wanted to do minus, no, I did want 14, duh. Okay, here we go. 14. Right. I hit enter. You technically don't need to, but all right. So you can just hit the graph key and it'll generate a graph on however you had the axes configured previously. If you're ever trying to set the axes up rapidly, you can go hit that key labeled zoom. The guy most people are familiar with is entry number 6 here, the standard zoom that sets your ranges on both the X horizontal and Y vertical axes from -10 to 10. Anyway, so I'll do that. And we get this thing. It's not super pretty. I put in a quadratic. I've got the graph of a parabola. Hopefully that's not surprising. So that's set up. If you wanted to adjust things a bit more manually, so for instance, if you don't like how we're missing the bottom of this guy here, you could manually go in and adjust things by pressing the window key right there. So then I'll go down and I'll adjust the minimum Y value. I don't know. We'll try -30 and see if that works. That's going to make the little tick marks on the vertical axis really close together because I'm putting such a wide span on there. If you wanted to adjust that, you could come down and change this Y scale to I don't know, 5. We'll do that. So that means the tick marks are going to be only every 5 units instead of every 1 unit. So let's see if that does enough. Nope, not quite. We're close though. So you get the idea on that front. Like I said, you could keep messing with it if you wanted to make sure you captured things, perfectly. All right. So we got that guy. Now, say we wanted to know where this thing crossed the x-axis. Knowing where something is equal to 0, or the x-intercepts of our graph, these 2 points right here, is pretty important. That's a thing we're going to be doing a lot as the semester rolls along. So, yeah, technically, you could hit the trace key and try to move the cursor along and get like a best guess to where they are. But there is actually a command that'll let you track them down more precisely. So if we hit second and then do calc, which is the second function of that trace key, the command we are going to be after is entry number 2 right there, 0. So we hit that, and it only tracks down 1 0 at a time. So let's go find that first one. So you'll notice it asks for a left bound down here. So I found that. I used the arrow keys to move my cursor up to the left of where I crossed the axis. Then I hit enter. Put the little arrow right there and then prompts me for a right bound. Let's move to the other side. There we go. Hit enter again. Now you got this little, pin down thing here, and it looks like our cross through is between those two arrows, which is what we want. Now, it asks for a guess. If you've played your cards right, you shouldn't really need to worry about this too heavily. Most of the time, I just tell students hit enter again. If you've narrowed down your, brackets tightly enough, this shouldn't be a problem. So I'm just going to hit enter on the guess, and lo and behold, I have an x coordinate of -1, y coordinate of 0. Sometimes this might not read exactly 0. It might be like a really tiny number, like it'll say 2e -14 or something like that. That is a number so small that most of us would just say, yeah, it's efficient. It's effectively 0. So that's that first guy. So we wanted to go after the second one. Same command. You don't necessarily have to use the arrow keys to trace things around quite so laboriously. So I can tell my graph doesn't cross the axis again until I get like over here. Spoilers, it's going to be at 7. But anyway, so you can actually just type in an x bound. So I just did x equals 0 because I know that's on the left side of where I cross here, but it's past this first guy. So I hit enter. It generates my little arrow there. I said, I'll type in 9 for that last one. Hit enter again. Now I've definitely got that crossing in between my two arrows. Hit enter one last time. And shazam, we have x equals 7, y equals 0. So that's, sketching a graph, playing around with the graph axes, and how you can, track something down using the 0 command. Look for one of those, x-intercepts on your graph. Or you might hear us refer to them as the zeros of a function. So the last thing I want to take a look at is several times over the course of the semester, we're going to end up generating a whole lot of values for a function. And yeah, technically you could type those things in repeatedly, but we've probably all got better things to do than just keep executing the same calculation for ever so slightly changed numbers over and over and over again, right? Right. So you can use your calculator to generate a table of values for whatever you happen to be after. So I've still got my function entered here. If you had some other x expression, we could fill that in. I'm just going to work with the same quadratic guy that I've already got. To set things up in the first place, we're going to hit the second key and then come up to this window guy where it says table set. So I like to configure my table settings like so. So it gives you a thing where it'll automatically generate a table of values. I'm a little more hands-on with that. So I always come down here and configure this thing that says independent. So my independent variable, I switch it so it's highlighted to ask. That way, I'll be able to enter stuff. So you'll see what that means in just a sec. So now that I've got that configured, I hit second, and that graph key up above it in the second function, we have table. So I hit enter there. Now you'll notice it's got a list x values, y1. If I had more functions, y2, y3, so on and so forth, we could use them. But so if we wanted to know, say, we wanted the y-intercept of this function, I mean, you can figure it out. Not pretty painlessly since it's a quadratic. But so if we want to know what was happening when x is equal to 0, I type in x equals 0, I hit enter, and I get my y-intercept value of -14. Then we could generate some more of these. Well, what's happening if we plug in x equals 5? 24. What about if we do, if you wanted to do like -2, do remember if you want a minus sign in front of something, make sure you use this key down here, the negative. If you use that one right there, that's a subtraction, and the calculator is going to get really fussy with you. So let's see what happens at -5. So we got 96, pretty big number. So you can use that to generate a table of values for you, and it saves you an awful lot of repeatedly typing the same things into your calculator's home screen over and over and over again. So I think that covers the key facets I wanted to make sure everybody was comfortable with on their calculators before we dive in. Like I said, we'll be using these pretty often as the semester rolls on. So that's it for now.